Hello everyone. So today we are going to solve some few more questions related to binary search on answer. Okay, so in previous video also we have seen two questions related to minimum answer, minimizing the maximum answer kind of questions. So this is the question which says that you are given an array with unique elements of stalls, which denotes the position of a stall. You're also given one integer k, which denotes the number of aggressive cows. Your task is to assign stalls to k cows such that the minimum distance between any two of them is the maximum possible. So, what you have to do? You have to find the minimum distance to be as maximum as possible. So, in this case, you have to maximize the minimum answer. Maximize the minimum answer. Okay. Minimum distance you have to put, but that minimum distance needs to be as max as possible. So for this type of questions, we have seen this pattern where it will be TT, and then FFF. So minimizing the maximum answer. Okay. So that means this should be your correct answer. Okay. From all minimums, your answer should be as max as possible. So we have learned the template for maximizing the minimum answer also. And that we will use over here. We have to maximize the minimum answer. Okay. Minimum answer is minimum distance that we need to make as max as we can. Simple. The question says that what we have to do. Okay, now your solve function will include what? Your mid will be the distance between the two stalls. Okay, so let's say you have made mid as the distance between two stalls. So how many cows you can put if you make mid as your distance between two stalls? So let's consider that this is the array. It's given only, right? 1, 2, 4, 8, and 9. So let's say my mid is 3. So I'm targeting that this distance between two stalls should be at least 3. So if I put my first cow over here, I cannot put my second cow over here. So I need to put my second cow over here. And then I didn't have to put, I can put my third cow over here. And then I cannot put any more cows over here on 9. So how many cows I can put? 3. So this 3 is equal to 3. Okay, let's consider another scenario where your mid is, consider your mid as 4. 1, 2, 4, 8, and 9. So you put your first cow over here. You will not put your second cow over here. You will not put your second cow over here also because the distance between this will be 3. Okay, 4 minus 1 is 3. So here also if you put your second cow, it won't affect. So it will affect, sorry. So you have to put your second cow over here. If you put your second cow over here, you cannot put your third cow over here. Correct? So how many cows in total you can put? 2 only, which is less than 3. So this could not be possible. Okay. What if my mid is 1? And I have again this stalls array. So you can put your first cow here, your second cow, third cow, fourth cow, fifth cow. 5 cows you can put. So our condition says that we need that distance such that we can put k cows. So if I put 5 cows, if I'm able to put 5 cows, for sure I'm able to put 3 cows because this is greater than equal to 3. So in your solve function, you have to count number of cows which you can put with stalls having having distance mid, and that count should be greater than equal to k. If you are able to put more cows, for sure less cows means k cows, of course you can put if you put more than k cows. Okay, but if you're able to put less than k cows, then you cannot put k cows. Our condition says that we have to put only k cows, only k cows. I hope you got my point. Let's solve the question in the coding that only, in the GFG only. This is the GFG question. So let's solve the question over there directly. Fine. So we'll first have our solve function, of course. So the solve will be mid, and then we have this stalls, and then we have k. And we will have the total number of cows. How many cows we can put. Okay. And let's say initially I'm starting putting from 0. So if this stalls is not in sorted order, we will sort this. So it's not given that stalls are in sorted order, so of course we will sort it. The stalls we will sort, so that it's always beneficial if we start from the first stall, putting it from the first stall. So currently I think I have put one cow on stalls of 0. Okay, my stall size will be at least 2, will be at least 2. Okay, so let's say I've put first cow on stalls of 0. So my count also I made 1. So count is number of cows I can put. Number of cows I can put. Okay, so I have put the first cow on stalls of 0 only. Now I have to check. Now what you need to check, that if you are on stalls of I, then the previous which you have chosen where you have put your stall, if that distance is greater than or equal to mid, it's fine, because we have decided the distance to be at least mid. So if my this stalls of I minus previous where I've put my cow is greater than equal to mid, I mean I have no issues. So I'll make this as now my previous, because I've put one cow over here, and I can make I can increase the number of cows. But what if it's less than mid? What if it's less than mid? Then you don't have to do anything, right? If it's less than mid, then you will not put the cow at that place. Done. And this count should be greater than or equal to k. Okay. Now what could be your L and R in this case? Uh, your minimum distance should be, of course, 0. Okay. Minimum distance between two stalls, of course, it should be 0. And your maximum distance could be what? They have said that you will be given at least two stalls. Okay. You will be given at least two stalls, and you have at least two cows. Okay. At least two cows. So if worst case scenario will be two cows and two stalls, so you have to put one cow at first index and second cow at another index. Or let's say you have only two cows and full this stalls array is sorted, then you can put first cow at 1 and second cow at 9. So minimum number of cows they have given is 2, so you have at least two cows in all the questions. It could be more than that. Then the distance will of course be between L and R, but maximum distance could be stalls of 0, stalls of n minus 1 minus stalls of 0. So for that we first need to sort this stalls array. Just to clarify, this stalls function, this sort function is the C++ STL function. Okay, and let's say we have this. So we have stalls of n minus 1 minus stalls of 0. I hope I'm clear. Okay, now we are done with our approach. So while r minus l greater than 1. Now here we need to find the maximum answer. We need to find the maximum answer. Maximum distance, right? So if it's possible for mid distance, if it's possible for mid distance to accommodate k cows, then we can try for something greater than big. So we'll put L as mid, and we can try from that mid to n minus 1 or r. Otherwise, if it is not possible, then we have to decrease our distance. So what we'll do, we'll put r as mid minus 1. So this template we have learned already in one of the video. If you have not watched, you can go there and watch out that first. Okay, now as these answer we need to maximize, we'll first check for the R for sure. So if it's possible for R, we will return R, else we will return L. I hope you got the question and you got the solution also, and how we are approaching this type of solutions. Clear? I hope you have got it. Okay, so now I'm targeting to cover one more question. Let's move to that. So there is another question which I found on Leetcode, which is actually good related to binary search. This would not be on the binary search on answer type of questions as what we are doing until now, but good question. So the question says that we need to implement a snapshot array that supports the following interface, and it has been asked in many good companies I've seen. Okay, so the question says that we need to implement a snapshot array that has this all features, this four features. First is snapshot array int length initializes an array like data structure with the given length. Initially, each element equals 0. Now there are three functions. Void set index comma well sets the element at the given index to be equal to well. Okay. Int snap takes a snapshot of the array, screenshot, snapshot, and returns the snap ID, which is the total number of times we called snap minus 1. Okay, snap ID is the total number of times we called snap minus 1. So if this is the first snap, the snap ID will be 0. I hope you got 0 based indexing. Okay, and then there is third thing, int get index comma snap ID. So we have to return the value at the given index at the time we took the snapshot with the given snap ID. Let's make it simple. So let's say your snapshot array, you are given snapshot array of length, let's say 5. Okay. Each element will be 0 initially. Okay. Now, now you are given, let me go with this thing. Cool. So now you have been given a set method first. So we have to first set index comma well, right? Index comma well. Okay. So I'm taking the set at second index 3. Okay. So 0, 1, 2, 3, 4. There will be 4 this 0, 1, 2, 4. At second index, so this is the snap ID will be, snap ID won't be there, but this is the first time. Now I'm not taking the snap, but I'm setting the value 3 at index 2. So at index 2, I'm taking it as 3. Okay. Now I'm calling the snap. So I'm taking the photo of this array. So this will be my snap ID 1, 0, sorry, because I'm calling it for the first time. Cool. Let's say now I have done set um 3 comma 4. Okay. So this third index will be changed to 4. I've again take the snap. After this, I'm again taking the snap. So my snap ID will be 1. My snap ID will be 1 at this point, and this is the photo of the array. Cool. Now I'm doing set 2 comma 6. So I'm changing the index of 2 from value 3 to 6 now. Okay. I'm again calling the snap function. So this is taking the photo of this. After photo, my array will be, so this is the photo I'm taking, and the snap ID will be 2 at this point because I'm calling snap third time. So snap ID will be 2. Okay. Now the get function comes, and get function says me that for index 2, I want I want the value at index 2 when the snap ID is 0. So when the snap ID is 0 at this point, I want the value at index 2. Value at index 2 is 3. So I'll return 3. Okay. Now it is saying me get to 1. So I want the value at index 2 when snap ID is 1. So when snap ID is 1, this is again 3 only. I hope you got my point. Okay. So we need to store it in such a way that we have index and snap ID. So at this particular index and at this particular snap ID, we have this particular value. We have to store it in that way. So what data structure we can use first here? This is the main play game of data structure choosing only. What is the data structure that we can choose over here? Where we have this kind of thing. Map will be easier for this kind of things. Okay. So what we can use is map of integer, comma, again map of integer, comma, integer. Where this will be the index, this will be the snap ID, and this will be your value. So at this particular index, at this particular snap ID, what will be your value? So for all index 0 to n minus 1, okay, you will go through all the snap IDs available and you will store. Cool. Now let me just give you the brief up of this. So initially what you have done, initially for all map of I comma 0, you have stored it as 0. Okay. If you won't do this, it's okay, fine. For initialization, if you want to do, you can do this. If you don't want to do, it's okay. So this is the optional step. Okay, not an optional step. Not an optional step. Why? Uh okay. So let's say I'm not storing this. I'm not storing this. Okay. Now consider the first thing came is like set 2 comma 3. So what I'll do? I'm setting 2. I'm setting 2 second index as the value of 3. As the value of 3. So at that time my snap ID will be what? Initially my snap ID will be, of course, I'll make a global variable of snap ID as 0. Okay. So when I'm doing set 2 comma 3, that means I'm putting the value of 2 at 3 and my snap ID at that point is 0. So what I'll do, map of 2 comma 0 is equal to 3. Right? Right? And then we took the snap. Let me write it over here. So map of 2 comma 0 is 3. And then we called the snap. So I increased my snap ID to 1 now. As we call the snap, I'll just increase and make it 1. Next time I have done set of 3 comma 4. So set of 3, sets snap ID will be 1, value 4. Again I have called the snap. So now my snap ID has become 2. And then I'm setting 2 6. So map of 2, snap ID will be 2 and value will be 6. So these are the 3 different values I have in my map. Now I'm calling get. Now I'm calling get. So first time I have called get for 2 comma 0. So get 2 for snap ID 0. So I have that value 2 comma 0. So I'll return simply from the map as 3. What if I call get 3 comma 0? I didn't have anything 3 comma 0 in the map. So what will I do? I need to return 0. So initially every value is 0. So we have to store this initial value. And if we are setting it somewhere and then taking its snap, of course it will change later at the later stage in our set function. So we need to store this initial values. So that next time I'll call 3 comma 0, all map this I will be for all I from 0 to n minus 1. So map of 3 comma 0 will be 0. It will be stored as 0. Now new issue may arise. What issue? After get 2 0, I have called get 2 1. So what is the value at index 2 when snap ID is 1? But it's not stored. Only 3 values I have. Or let's say these all values I have. Map of 1 comma 0, 2 comma 0, 3 comma 0. All 0 values I have until n minus 1 0. But then for 2 1 what? I just have 3 1, not 2 1. That means I didn't have I didn't change the value at index 2 when I took the snap at 1. If I have changed, that would be there in my map. All changed values are here. Why? Because we are setting in the map when we call that set function. But I didn't have any value, so I didn't have changed at first index. Whatever be the previous index before this, so I need to find somewhere where 2 is changed before 1. That will only be the value constant until this point. So initially at before 0th snap, I made it like 3. And then I changed third index as 4. But I didn't touch second index. So second index will be same when I took the snap ID at 1. When I took second time snap. So I need to found the upper bound. I need to found the upper bound. So let's say now I'm getting get 2 comma 1. So if 2 comma 1 is present, it's okay, I'll give if 2 comma 1 is present. If it is not present, I need to find something lesser than it. So what I'll do, I'll find the upper bound of this 1. I'll find the upper bound of snap ID. Upper bound of snap ID in map. Okay, so I'll get upper bound as 0 and then I'll return map of 2 comma 0. I hope you got my point. The same case, let's say map of 2 comma 2 is 6. Okay, what if I have asked get 3 comma 2? So I have only 3 comma 1. I didn't have 3 comma 2. Okay. So for 3, so for map of 3 is what? Map of 3 is what? This value 1 comma 4. Only this one thing for map of 3. Okay, two things, 0 comma 0 and 1 comma 4, right? Initially it will be stored as map of 3, 0 is equal to 0. So 0 comma 0 and 1 comma 4. So I'll find the upper bound of 2 in map of 3. So I'll get this one. Sorry, I'll get something beyond 2. Okay, something greater than 2, but it's not present. I'll get map dot end at this point. So I'll do 1 minus. So I'll get at 1 comma 4. That means whatever be my last changed value, it will be same if I have not changed while taking the snap at snap ID 2. I hope I'm able to make you understand clearly. Let's try to code it. Okay, so we will first have a map of int comma int, and this will be index comma snap id comma well. So map of index is again what? This map of index is again what? A map, because the first key value pair is key is int, but value is map again, map of int comma int. So map of index is a map where we can apply upper bound. I can put pair also as the value. Map of int comma pair of int comma int also I can put, but that will be we didn't know a direct method to apply upper bound. We have learned three ways simply, on 1D vector, on map, and on set. That's why. Okay, so initially we will do what? For int I0, I less than length, I plus plus, I'll do map of I comma 0 as 0. And also I'll have one snap ID over here, which will be initially 0. Now every time I'm setting, what I'll do map of index comma snap ID as this well. And whenever I'm taking snap, I'll increment the snap, but I'll return what? Snap ID minus 1. Okay, this will increment the snap. So first time I've taken the snap, but return will be 0, minus 1. Okay, so now forget if it's already there. So if map of index dot count snap ID, all index will be already present as we have done with initialization only. Okay, so if this snap ID is present, then we will return this snap ID itself. No need to worry. Otherwise, we will find the upper bound, map of index dot upper bound, and then the snap ID, of course. So 2 comma 1 is not present. So we will find the upper bound of 1 on map of 2. Okay, so if it's not found, if something greater than 1 will be found, it will return that, or if not found, it will return map of 2 dot end. So I need to do 1 minus minus pointer, and then I need to return its value. So this value will be it's second value. This will already be something map of 2 comma 0, because after minus minus it will be 0 if I've asked for the 1. I hope you have got it. A little bit trickier question, that's why it's asked in many of good companies. So let's try and submit it. I hope you have got it. I'll be covering one Leetcode hard question in the next video. That was also a very good question, which I found in the recent daily challenges in May 2025 only. Okay, so I'll be covering that. It's a very good question. Stay tuned for the next video. Do like, share, and subscribe if you have learned a lot out of this.